In the figure which is drawn to scale, find the radius of the larger circle in terms of R, A and B. This is quite an easy problem. All you need to do is figure out which are the additional elements that you need to add to this figure. Obviously, as it is, you can't do much about this. There's no way you can get more information. So what elements can you draw to this figure which will give you more information? A good approach is always to try the most intuitive auxiliary elements. In this case, you would want to draw the radii from the radii of both the circles to this line here, because these are the line segments for which we know the lengths, and this line is a tangent to both the circles. So it makes a lot of sense to draw these two radii. So we'll call the triangle ABC, and E and F are the points where BC meets the two circles. Let's draw the two radii, O1E and O2F. And so O1E and O2F are both perpendicular to BC because the tangent is perpendicular to the radius, right? And we know the lengths of these segments, DF and ED. So again, the next intuitive elements to add would be the hypotenuse of these two triangles, because you know, at least here you know R, you know this length, and so you can find the length of the hypotenuse. Here you know the length of one of the segments, and this is what you want to find. And so draw these two hypotenuse, right? And that is all you need to do. Now if you draw a neat figure, the solution will be right in front of your eyes. Here you can clearly see that O1D O2 has to be 90 degrees. Why? O2D bisects this angle ADC. Why? Because AD and DC are both tangents drawn from the same point to a circle. And so the line joining the radius and the point bisects the angle ADC, which is quite easy to prove, right? You draw the radius over here. What you will see is these two triangles are congruent because the hypotenuse is shared and both these sides have the same lengths, and therefore the third side must also have the same length, which gives us two congruent triangles. And so ADO2 and CDO2 must be the same angles, which means O2D bisects ADC. Similarly, O1D bisects ADB, and this angle BDC is pi, right? So you have a situation like this. You have BC here and you have AD here, BC and AD, and you have these dotted lines bisect these two angles. And therefore, if this is alpha, this is alpha. If this is beta, this is beta. This whole thing is 180 degrees. So 2 times alpha plus beta equals pi, and therefore alpha plus beta must be equal to pi by 2, which gives us O1D O2 is pi by 2. So if this is pi by 2, the sum of these two angles, O2DF and O1DE, must also be pi by 2. So if we call this alpha and this beta, alpha plus beta must be equal to pi by 2. And therefore alpha is pi by 2 minus beta and beta is pi by 2 minus alpha. Consider these two right angle triangles now, O1ED and O2FD. This angle equals pi by 2 minus alpha, and so it must be beta. And this angle is pi by 2 minus beta, and so it must be alpha. And therefore these two triangles are similar. Triangle DFO2 and O1ED are both similar. And therefore the corresponding sides have the same ratios, which gives us O1E by ED equals DF by FO2, O1E by ED equals DF by FO2. We know 3 of these sides. O1E is R, ED is B, DF is A. We want to find the other one. We'll call it X. And therefore X equals AB by R. The radius of the larger circle is AB by R.